Hello, this is Cloud Computing Team 6. My name is James Cote, and I'll be discussing Kubernetes. More specifically, I'll be discussing deploying a full-stack web application to a Kubernetes cluster and explain the benefits it can bring to reliability and maintainability of such an application. The objective is to gain a better understanding of Kubernetes. Additionally, I wanted to understand how Kubernetes can automatically provision and scale deployments, as well as other benefits it brings to maintainability of a web application. So, contributions. So what did I accomplish in this project? So I was able to deploy a simple full-stack web application using React Node.js for the front end and Golang for the back end, and I will demonstrate this application later in the video. Additionally, I was also able to create a horizontal pod autoscaler and demonstrate it in action by load testing a computationally expensive endpoint in my backend, which I'll also demonstrate later in the video. I will go over some core concepts of Kubernetes and explain how my demo project utilizes them. Afterwards, I will begin to demo the application and show it in action. First, what is Kubernetes? Kubernetes, which takes its name from the Greek word for helmsman or pilot, is a container orchestration platform. It will deploy application code as containers to the cloud and automatically scale them to handle user demand. Additionally, it contains capabilities for automatic upgrades, failover, and much more. It essentially automates provisioning and scheduling of application resources across a fleet of machines. There are many ways you can set up a Kubernetes cluster. You can host your own on any of the major cloud platforms, or you can use a managed Kubernetes as a service, which is what I chose for this project. Google offers their own managed Kubernetes service called GKE, or Google Kubernetes Engine, which is what I went with. So, a quick review on containers. A container is a standalone process that is isolated from the rest of the underlying operating system and contains only the necessary system files for a given application. Containers are beneficial from a reliability standpoint, as you can be sure that the application will run the same way on any of the operating systems that can run the container engine. Docker is a popular container engine introduced in 2013 and is the main container engine supported by Kubernetes. For my project, I created two separate container images, one for my front-end web service and one for my back-end web service. I deployed these two container images onto my Kubernetes cluster, as well as container images for Redis, which my application connects to for data storage. A pod is a collection of containers within a Kubernetes cluster that share the same storage and network configurations. My front-end and back-end web applications are each deployed as separate pods within the cluster. The Redis cluster, which consists of master and slave Redis instances, are also each deployed as separate pods within the cluster. A node is a computing resource, either a VM or a physical machine, and its responsibility is to run pods and execute commands from the master server to ensure the pods are in a desired state. Each node contains a container runtime to run containers, kubelet, which manages the execution of containers, and kubeproxy, which is responsible for providing network rules to allow pods to connect to resources inside and outside the cluster. The cluster for this demo was created with 3 nodes. Replica sets run a specified number of pods based on a template. It's a fundamental building block of Kubernetes, and it's managed by deployment objects. Replica sets are responsible for scaling up and down pods. Deployments create and manage replica sets, and when creating a deployment, users can specify things such as CPU and memory requests, the container image, or images to use in the pods, among other things. Services target pods deployed by a deployment and allow them to communicate with other pods. Each resource within my cluster, which is the front end, the back end, and the Redis master and slaves, all have separate deployment and service configurations and specify how the pods for each of these resources should be set up. An application will usually expect configuration values in order to function correctly, and that can include environment variables or files. Config maps and secrets allow for a secure way of transmitting these values to containers without leaving them inside the container. In my demo, I make use of Google Cloud Translation API, and a config map value is transmitted for the path of the file, and the API secret is volume mapped as a secret. So, in my demo, I will show off my application simple blog, which is deployed on GKE. I will then show off how I deploy each of the application containers and each of the Kubernetes objects used. I will then round off the demo with some monitoring tools and scaling demonstration. So this is the web dashboard for GKE on Google Cloud Platform. And as we can see here, there's a single cluster called Simple Blog for the web application. And there's 3 nodes that are allocated within this cluster. And over here, we can see 4 deployments. And there's also a pod there, which we'll use for the load testing. So you can see that there's 2 deployments for the Simple Blog application, the back end and the front end. And there's also 2 deployments for the Redis master and slave, which the Simple Blog application will connect to retrieve and store data. And over here, there's 2 node port services for the backend and front end. And then there's 2 cluster IP services for the Redis master and Redis slave. And there's also a Simple Blog ingress, which is a load balancer that will hook up to the backend and front end node ports. So we can see here, there's a post, and we can see how that looks right here. And we can translate it. So we can select from one of these 3 languages. It's in English, obviously, so we can pick one of these. And so we can see how it looks in French. And we can also see how it looks in Spanish. If we want to create a new post, we can just go like this, and we can create the post. So we can see here that may request the backend. And you can see blog post successfully created, sent from the backend. And we can see here that it loaded the blog post. And we can also translate this too. For the final part of the demonstration, I will show off the capabilities of the horizontal pod autoscaler. On the left, I ran some monitoring commands to see information for the overall cluster. The HPA is already installed as well. As we can see here, that for the autoscaler, I have a target CPU utilization of 50%, which means that I am looking to have all the pods have an average CPU utilization of 50%. Right now, that is the current CPU utilization. And what I have over here on the right is I have a shell open inside the load generator, which is this individual pod right here. And what I'm going to do is spam the API at this endpoint that I created right here, which is just a simple computationally expensive operation. We should expect to see the current CPU utilization to go over 50%, and the autoscaler will deal with that by allocating some new replicas. So I'm going to run that right now. So as we can see here, the result of an endpoint is being output to the screen here, and I'm going to check up on the HPA. So right now it's at 1% still, but should be at a minute or so and it will update. And I will also cut this video as well because it does take a few minutes for the pods to be autoscaled. So we can see now that it's at 104%. And you can see also that there are now 3 replicas, which we can see here. So you can see these are the newest ones here. This one's still being created. And we could also describe the HPA. And we can see right there, there's a successful rescale events. Now it's at 232%. And now we can see here that we have gone up to 5 replicas. So as you can see here that there's another successful rescale event. And we can see right here, these 2 are the newest ones. So now I'm going to end this command just like that. And we should see now that in just a moment, the current CPU utilization will go back down to below 50%. And we should expect to see the replicas will also drop back down to 1. And again, I'm going to do a cut as well, just because it also takes a few minutes to scale back down to 1. So now it's at 1%. So now we can see here that the number of replicas has gone back down to 1. You'll see right here, it went down to 4, and then now it went back down to 1. And you can see the reason here, all metrics below target. You can see here, there's now just one backend pod. And that concludes the demonstration. So future work on this project includes, but not limited to, the following. Firstly, I would explore autoscaling in greater depth. I only had the time to demonstrate a simple example of horizontal scaling, but you can also vertically scale resources, meaning that you can scale node resources such as CPU and memory, and you can also do cluster autoscaling, meaning that you can increase or decrease the amount of nodes within the cluster. Another thing I would work on in the future is to improve the security of the Kubernetes cluster. I would add features such as TLS on each endpoint, I would run containers as a non-root user, and I would add network policies to restrict pod-to-pod traffic. I would also use a tool such as Terraform to streamline my Kubernetes infrastructure deployment. If you want to learn more about Kubernetes, you can check out the resources below. There are 2 tutorials, one on deploying a simple guestbook application backed by Redis, and another on deploying any application with a Docker file to GKE. There are also 2 great blog posts explaining more in depth on the core concepts of Kubernetes that I recommend checking out, and there's also another good blog post that talks more in depth about pod autoscaling that I also recommend checking out. So what worked for this demo? I would say what worked was the fact that I was able to demonstrate a full stack application running on Kubernetes, which I believe is a valid real world use case of Kubernetes. What did not work for this demonstration was the lack of more complex scenarios. Additionally, I did not have time to elaborate on aspects such as scaling, monitoring, security, and cost effectiveness. If I had to change something within this project, it wouldn't be the platform or the resources, as I believe that GKE and Kubernetes are a great fit for this project. What I would change is to prioritize more on the Kubernetes aspects of this project. As mentioned earlier, there's more aspects I wanted to explore with, such as autoscaling and cluster monitoring, but unfortunately I did not have time to do this, so that's something I would have tried to focus on instead. And that concludes the presentation.